Hi, this is third grade math for second week of April, and we're going to be doing area of figures. Go ahead and get this from your packet because you're going to be using yours to follow along with me. While you're getting it, area of figures is a little different than area of rectangles. So if you're doing area of rectangles, it's just length times width. And we're going to start with that. But later in the packet, it's going to get a little more complicated. Okay, do you all have yours from your packet? Give you a little bit more time. Okay. So a rectangle is a figure with 4 sides and 4 square corners, and do you guys remember we call square corners right angles, and that's where the word rectangle comes from. And to measure the area of a rectangle, you need length times width. They show you that here where they've taken that rectangle, same rectangle, and actually shown you with lines. They're chopping it up, and so your length is 4 and your width is 2. And they're calling them units because they could be inches, they could be centimeters, units of measurement. Down here, you do the math, 4 times 2. Skip count your 2's, 2, 4, 6, 8. 4 times 2 is 8, and that's the area. Go ahead and go to the next page. This one is a lot like the one you just did, except the measurements are different. The length is 5, the width is 3. Length times width means 5 times 3. It's easier to do 3 5s, so let's just do that. 5, 10, 15. And 5 times 3 makes 15 for the area of that rectangle. By the way, you just used, when you did 3 times 5 instead of 5 times 3, you used the commutative property. Just a quick reminder. Okay, here we have a word problem. Miss Walker bought a new rug for her living room. What is the area of the rug? You've got 9 feet for the length and 6 feet for the width. And they're actually wanting us to use the distributive property down here. But first let's do 9 times 6. And they flipped it and made 6 times 9 because that's easier to do, because 9s are easier than 6s, so we'll do that. 9, 18, 27, 36, 45, 54. 9 times 6 is 54. So her rug is 54 square feet because they gave feet as the unit of measurement. Over here it's telling you to try it again with the distributive property. No, it's a new problem. To find the product of 8 times 9, you can break apart the factor 9 into 5 and 4. So 8 times 9 is the same as 8 times 5 plus 4. You can multiply the 8 by each of those two add-ins, and then you can add the two products you get. So going back to 8 times 5 plus 4, which you got from there, it's the same as 8 times 5 plus 8 times 4. 8 times 5 makes 40. 8 times 4 makes 32. 40 plus 32 makes 72, so 8 times 9 makes 72. Let's go to the next page. On this page, they want you to find the area of this rectangle, and it's 6 units and 7 units. So 7 units is your length, and they want you to use that distributive property. They want you to break apart the length of the rectangle into two different add-ins. The length of the rectangle is 7, break the 7 into 5 and 2. And as you guys know, that's going to be a lot easier than 7s. Draw a line to separate the 7 units into 5 units and 2 units, and they've done that right here. Now they want you to multiply the side lengths. The length of the rectangle is 5 plus 2. You get that from the 7 units. The width is 6 units. You're going to multiply using the distributive property. 5 plus 2 times 6 is 5 times 6 plus 2 times 6. 5 times 6 makes 30. 2 times 6 makes 12. You add those together and you get 42. So the area of the rectangle is 42 square inches. Just so you know, if you knew your 7s, you could do 7 times 6, and it does make 42. But it's a lot easier if you don't know your 7s to split the 7 into 5 and 2, because you all do know your 5s and 2s. Let's go to the next page. And here's the part where it starts getting a little more complicated. Some figures can be broken apart into 2 or more rectangles. And this is definitely going to be one. So here's one way you can break this figure apart into 2 rectangles. And here's another way you can do it. And then you can even break it into 3. The area of each part can then be added to find the area of the entire figure. So let's try it. Example 4. The diagram shows the dimensions of the living room and dining area of Mr. Klein's apartment. Find the total area of both rooms. And this time our unit of measurement is yards. Okay, you can see that he's got a dining area here and a living room here, and a lot of different measurements. Don't worry about those right now, because you want to go to your strategy. You're going to break the figure apart into rectangles to find the total area. Let's go to the next page and see how they do that. Draw a line on the figure to form the 2 rectangles. The dining area has a length of 3 yards and a width of 2 yards. So they want you to split it right about there. And you can draw over their line if you want. The living room has a length of 5 yards and a width of 4 yards. So even though it says 7 across here, you got to be careful. 3 of those yards you just took away and made part of the dining room. You kind of sectioned those off. So what's left of the 7 yards is only 4 yards down there. Find the area of each room. So the area of the dining area is 3 times 2, which is 6 square yards. And they get that from up here, 3 times 2, length times width, 3 times 2 for the dining area. The area of the living room is 5 times 4, which is 20. And they get that from, this is now our length. It used to be the width because this is the longest, but it's now our length because you sectioned it. And this is our width, 4. So 5 times 4 makes 20. Then you add those two. 6 plus 20 makes 26. So the total area of both rooms is 26 square yards. If you don't get that, one thing you can do is you can tile it. You can actually show the 3 and the 2 with tiles and just count them. And then the 5 and the 4, you can do the same thing. That gives you 4, and then 5, and then you can add those, and it will make 20, and that'll make 3. Let's go to the next page. The diagram shows the dimensions of Cheyenne's bedroom and closet. Find the total area of her bedroom and closet. So just follow each step. It says draw a line from the figure, on the figure, to form 2 rectangles. Label the dimensions of the rectangles formed. So what they want you to do is draw a line across here to separate the closet, and that way you now have a rectangle here and a rectangle here. And then I think it's already all labeled, so I don't think we need to add any labels. The closet has a length of something meters. And if you look up here, the longer side is 2 meters. So you're going to put 2. And a width of something meter. That's the short side. That's right here or here. And you can see that's 1. The bedroom has a length of, and you can look, the longer side of the bedroom is 4 meters. And a width of, the shorter side, which is the width, is 3 meters. Find the area of each room. Closet. So you want length times width, so the length is 2 and the width is 4. So you're going to put 1. 2 times 1. And you all know what that is. 2. The area of the closet is 2 square meters. Bedroom. And go back up here. You said that the length was 4 and the width was 3. So you're going to put 4 times 3. And then you need to skip count. 4, 8, 12. So the area of the bedroom is 12 square meters. Now you got to add them both together. So 12 for the bedroom plus just 2 for the closet. Closet's kind of small. 12 plus 2. What do you think it is? Yeah, that was easy, huh? 14. And the area of the bedroom and closet is 14 square meters. All right, let's go to the next page. It says, look at the measurements for each length and width of a rectangle. Is the area of the rectangle equal to 20 square units? Select yes or no. A, length 5, width 4. All right, let's do 4 5s. 5, 10, 15, 20. That's a yes. B, length 5, width 5. Well, this time we're doing length times width again, but it's 5 and 5. 5, 10, 15, 20, 25. Is that a yes or a no? Yeah, it's a no. Oop. Sorry. C, length is 10 and the width is 2. So we'll do length times width, 10 times 2. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. 10 times 2 is 20, so it's a yes. D, length 10, width 10. Well, that sounds like it's going to be a bit much, so let's try it. 10 tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Way too big. That's a no. Second problem. Cody says these two figures have the same area. Is he correct? Use words, numbers, or models to explain your answer. 4 and 9 for our length and width, and 6 and 6 for length and width. So down here, you can either draw it or do math. Drawing's pretty fun, but the quickest way to do it is with math. So if you want to draw it out, you can make tiles and show 9 and 4, but we're just going to do that as a problem. So 9 times 4, length times width. And let's name this guy, let's name this one Bob. Okay? Bob is 9 times 4. And the easiest way to do that is to do the commutative property and do 4 times 9. 9, 18, 27, 36. Okay? Let's name this one Sue. So Sue, you've got length 6 and width 6. So length times width, 6 times 6. And I hope you guys remember, 6's are thirsty 6's, so 6 times 6 is 36. Good. And then down here you can write 36 equals 36. So Cody is correct. They are equal. Give you a second to write that. Okay, next page. Number 3. Which is a way that James can use to find the total area of this figure? Well, I got a few different ways here. Let's try the first one. A, 6 times 3 plus 7 times 3. Depends which way you split this, but let's go ahead and do it like this. And that does give us 6 times 3, length times width for this guy. So that would be correct, but is the other one 7 times 3? Is this one 7 times 3? Well, it's not, because that whole width length there is 7, but you just sectioned part of it off. So you've only got 4 left here for the length and 3. So 7 times 3 will not work. So A is not going to work. Let's go to B. 6 times 3 again, that's this one, plus 7 times 4. Well, is this 7 times 4? Nope. Okay, that one's not going to work. Let's try C. 4 times 3. Do we have a 4 times 3? Yeah, right there. That's 4 times 3. So that's good. Let's try the other one. Plus 6 times 3. Do we have 6 times 3 up here? Yeah, we do. So C is good. D. 3 times 3. If we section it right here, we've got 3 times 3, don't we? Plus 7 times 3. Well, if you section it here, is what's left, is this one here, 7 times 3. The length is 7, the width is 3. Yes, it is. So D is good. E, 3 times 4, which we have right there, plus 6 times 3, which we have up here, plus 4 times 3. Well, we don't have a 4 times 3. So that's a no. Number 4, draw a line from each figure to its area. A, 1 foot for the width and 6 feet for the length. So we'll do length times width. 6 times 1 is 6. you're going to connect that with that. B, the length is 4 and the width is 2, so you do 4 times 2. 2, 4, 6, 8. You're going to connect that straight across. C, 3 times 3 makes 9. You're going to go up to the top there. And D, uh-oh, this one's a little harder, but guess what? It's got to be 7 because that's all that's left. Let's just prove it. If you split it right here, you get a square, and it's 2 times 2, length times width, which is 4. And then you get a rectangle over here, 3 for the length times 1, that's 3. So if this is 4 and this is 3, does that make 7? Yes, it does. By the way, before we go to the next page, is a square a kind of rectangle? Yes, it is. And that's why you can do length times width for a square. A square is a kind of rectangle. We're almost done. The good news is this lesson counts for all your math today. You don't have to do an extension once you're done. Number 5, Alejandro divided his garden into 4 equal sections. Each section is 5 feet long and 3 feet wide. What is the area of one section of the garden? And it's something square feet. So go to the part where it says each section is 5 feet long and 3 feet wide. So what's your length? 5. Go ahead and circle that 5. What's your width? 3. You can circle that 3. Okay, so 5 times 3. It's easier to do the commutative property and do 3 times 5. 5, 10, 15. What is the total area of the garden? Okay, go back to the beginning and it says Alejandro divided his garden into 4 equal sections. Circle that 4. All right, you already figured out that one section of his garden is 5 times 3, which made 15. But he's got 4 of those. So you need 15 times 4. So you're going to actually write an algorithm. Let's put it over here. 15 times 4. And you're going to do units first. Go to your multiplier. 4 times 5. 5, 10, 15, 20. Go ahead and put the 0. And the 2 has to wait in the basement or the attic in the tens column. Back to your multiplier. 4. 4 times 1. That's 4. Plus the 2 that are waiting. So that would be 6. And the total area of his garden is 60 square feet, which you could actually grow a lot of stuff in. Number 6, complete the table to find the missing side lengths or area. Ooh, this looks complicated. So rectangle A, you've got the length is 5 and the width is 2, but we don't know the area. Well, area is length times width. So you're going to do 5 times 2. 2, 4, 6, 8, 10. And you're going to put that for the area. Rectangle B, something, and for the length, and 6 for the width, and our total area is 42. So this time, you guys, we know all of the stuff, and we know part of the stuff, and we don't know the other part. So we're going to have to go backwards. This is a division. And so we're going to divide 42 by 6 and just skip count 6s until we get to 42. 6, 12, 18, 24, 30, 36, 42. And I've got 7 fingers up. So the answer is 7. The last one, once again, we're missing one of our factors. Those are, you know, when you multiply things to make a product, the things you multiply are called factors, and we're missing this time it's the width. So we've got our length, which is 9. Don't know our width, but our product or area is 27. So we're going to go ahead and skip count 9s and figure out how many of them to get to 27, because it's basically 27 divided by 9. So ready? 9, 18, 27, stop. How many fingers am I holding up? 3. Okay? Number 7, use numbers from the box to complete the equation to find the area of the rectangle. And if you guys see, they're using the distributive property. All right, you can see that your total length across here, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then your width is 3. But they're splitting the 9 into 5 and 4. Down here, they started the equation for you. 3 times 5 plus 4. And they get that from the 9, okay, is, and now you're going to put something times something. 3 times 5. And then plus something times something, back to the 3, 3 times your other addend, 4. And then they don't even want you to find the answer, but let's go ahead and do it. 3 times 5 is 15. 3 times 4 is 12. And 15 plus 12 is 27. Go ahead and circle the 3 twice. And then circle the 5 and the 4 once. Okay, we're going to go to the next page, and we're almost done. Megan set up 2 tables at the Arts and Crafts show to display her work. The diagram shows the identical tables Megan set up. Break apart each table into different pairs of rectangles. Find the total area of each table. So for the first one, let's go ahead and section off this top part. Looks like we're going to have a square table and a nice chunky rectangle table. What's the area of this part? Well, your length is 3 and your width is 3. So this is going to be 3 times 3, which is 3, 6, 9. Oops. Sorry. 9. Down here, you've got your length is 5, your width is 3. So 5 times 3, it's a little easier to flip that, do the commutative property, and do 3 times 5. 5, 10, 15. And now we're going to add 9 and 15. You can make an algorithm. 5 plus 9 is 14. Put the 4, and the 10 has to go in the tens column. And wait, and then 110 plus nothing is 1 plus this guy. That makes 2. So your total area is 24. we're going to write that down right here. What we just did, we did 3 times 3 for the top one. And it made 9. And then we did 5 times 3 for the bottom one. And it made 15. And then we added those together and it made 24. So you're going to write 9 plus 15 makes 24. Now let's deal with this one. It's the same, but you want to split it up differently. So you're going to go down and section it off like that. And this time you've kind of got a long, skinny rectangle and a shorter rectangle. Let's do this one first. The length is 6. Is the width 5? No, it's not. 5 is all the way from there to there. So go ahead and look up here. The width is 3. So for this rectangle, you've got length 6 and the width 3. So length times width, 6 times 3. Let's do 3 6s instead, it's easier. 6, 12, 18. Now we'll take care of this little guy. You've got your length is 3 and your width is only 2. So 3 times 2, length times width, 3 times 2. 2, 4, 6. You got to add that together, make an algorithm. Units first. 8 plus 6, that's 14. Go ahead and put a 4, and then your 10 has to wait. And then in your 10s, you've got 1 plus nothing, which is 1, plus this guy makes 2. You get to 24 again. Let's go ahead and write down what we did. We did 6 times 3 to make 18. We did 3 times 2 to make 6. And then we added them together to make 24. So you're going to say 18 plus 6 equals 24. Last of all, you need to prove that the tables are the same area. It's kind of fun. You just get to write 24 equals 24. Let's go to this next problem, number 9. A rectangle has a length of 6 units and a width of 3 units. Hannah says the perimeter of the rectangle is 18 units. James says the area of the rectangle is 18 square units. Who is correct? Use words, numbers, or models to explain your answer. So you could draw it out, you could make models. We're going to use math because it's the quickest, so we're going to use what? Numbers, okay? Let's go ahead and look at what Hannah said first. Hannah says the perimeter of the rectangle is 18 units. How do you get perimeter? Peri means around. Meter means measure. Animals that have peripheral vision can see all the way around. That's where we get peri from. So perimeter means all the way around. So we need all 4 sides of this rectangle. So if its length is 6, how many sides are there that are 6? That's right, 2, not just 1. It's a rectangle, right? It's going to have 2 sides that are 6. And then its width is 3. How many sides is it going to have with that length? 3. How many sides? 2 of them, okay? 2 short sides that are 3 and 2 long sides that are 6. So down here, let's put an algorithm. 6 plus 6 again for the long sides, plus 3 plus 3. And we'll do the math. 6 plus 6 makes 12. Plus 3 is 15. Plus 3 again. That's right, it's 18. Put the 8 in the units and the 1 in the tens. Okay, is Hannah correct? Yeah, she sure is. So next to that you can write Hannah is correct. Okay, let's look at James. James says the area of the rectangle is 18 square units. Now, area is different from perimeter. First of all, did you notice it said square units this time rather than just units? Perimeter is just units because it's just all the way around. And you measure distance or length, you just measure that with units. Area is square units, right? It's going to be chopped up into squares. So let's look at, we've got length of 6 and width of 3. How do you get area? Length times width. So we just need to do 6 times 3. Good. So over here somewhere, 6 times 3. Okay, let's skip count. Should we do 3 sixes? Let's do it. 6, 12, 18. Looks like James is correct too. That's always nice, isn't it? James is correct. All right, you used a little bit of words, but mostly numbers. I'm going to give you a minute to finish writing, and then we'll do the last page. Okay. Even if you're not quite done, let's go ahead and go to the next page. Alicia and Tyrell both draw a rectangle with a length of 5 units and a width of 4 units. Part A. Alicia adds 4 units to the width of the rectangle. She writes 5 times 4 plus 4 to represent the area of her new rectangle. On the grid, draw Alicia's rectangle. Label the length and the width. So remember, she started by drawing one that was 5 times 4. So you're going to start with the one she drew first. So we're going to go 1, 2, 3, 4, 5 squares down. And then how many across? Just 4 for her first rectangle, right? So 1, 2, 3, 4. And now turn that into a rectangle. Okay. But we're not done because it said that she added 4 more units to the width to make a whole new rectangle. So your width is your shorter length. You're going to add 4 more. 1, 2, 3, 4. And then do the same over here. 1, 2, 3, 4. Close it. And there we go. Whole new rectangle now. It's much bigger. Part B, use the distributive property to write the area of Alicia's rectangle as the sum of two areas. Then find the area of the rectangle. All right. Let's say this one's X and this one's Y. What's the area of X? Length times width. 1, 2, 3, 4, 5 for the length, and 1, 2, 3, 4 for the width. So we're going to write 5 times, and then for her first rectangle, put a 4. Now, how many is the width for her second one? It's 1, 2, 3, 4 again. So you've got another width that you're adding to make a whole big rectangle, and it's 4 again. So put a plus and 4. Now put an equals, and now let's write out what this really is. Equals 5 times 4, close your parentheses, plus 5 times 4 again. Okay, put another equals. Now let's figure out what each of those makes. What's 5 times 4? Well, do your commutative property and do 4 times 5. 5, 10, 15, 20. So we got 20 from this one. Put your plus sign. Look at your second set of parentheses, 5 times 4. Well, you just figured out what that was. It's 20. And 20 plus 20. I hope you all know what that is. Yeah. There we go. Last one. A square has a perimeter of 20 inches. Complete each statement. So the first thing you need to really think about is it's a square. That means all its sides are the same length. All right. The side length of the square is something inches. How many sides does a square have? Yeah, 4, and they're all the same length. So 4 times something makes 20. Remember, they all have to be the same. It's not 4 times something and something else. It's just 4 times something. Do any of you know what 4 times something makes 20? You might have to do a division to figure it out. So let's try that. We'll start with 20 and divide it by 4, so we'll skip count 4s. 4, 8, 12, 16, 20. Aha! 4 times 5. So the side length of the square is 5 inches. The area of the square, how do we get area? Length times width. Well, are the length and the width the same, or are they different? It's a square. Yeah, they're the same. So you're going to do 5 times 5 again. So skip count your 5s. 5, 10, 15, 20, 25. That gives us our area. And you are done with your packet, and you're done with math for today.